Hello friends, today we will discuss another important topic of molecular symmetry chapter, that is point groups. In the beginning of this chapter I told you that in molecular symmetry basically there is two parts that we want to understand. One is molecular symmetry elements and symmetry operation, and second one is point groups. So here today we want to learn a point groups. Before that point groups topic, we will just highlight what we saw in the last week. In last week we talk about what is molecular symmetry, how it is important, and then how we can understood or how we can understand the molecular symmetry with the help of symmetry elements and symmetry operation. There are basically 5 different symmetry elements that we had already learned. One is called as axis of symmetry, second one is a center of symmetry, third one is a proper plane of symmetry, fourth one is a improper rotational axis, and last one is a identity. And we also saw two important symmetry operation. One is rotation, another is a reflection. Without understanding any one among these, we cannot understand the, or we are not able to understand the molecular symmetry. So both symmetry elements and symmetry operations that are very important to understand the molecular symmetry. Now today we want to learn point groups. Point group is another very important topic to understand the molecular symmetry, because once we understood the symmetry elements and symmetry operation, then we want to take a collection of symmetry elements which are related to one another by certain rules. The symmetry groups are frequently called as point groups. That means when we collect all the symmetry elements which is present in a given molecules and they are grouped together, then it is also called as a point groups. So group means we want to group of all symmetry elements. So in definition we can say that point group is defined as what? Uh, a collection of symmetry operation that can be carried out about a unique point on a molecule and related to one another by certain rules. That means suppose I have H2 molecules, then in that H2 molecules whatever the symmetry elements or symmetry operations which are present on that molecule at a particular point, that all are collected together and they are related with one another by a rule. That rule is generally called as a point groups. Right? Everybody understood that? Again I will repeat. A collection of symmetry operation that can be carried out at a unique point on a molecule and related to one another by certain rule, that is called as point groups. Now what are different types of point group? We have different types of point group because molecule may have low symmetry. That is, what is low symmetry? That means basically two types of molecules, one which is called as a low symmetry molecules and other is a high symmetry molecules. Low symmetry molecules means what? That molecule have a few or no symmetry operations that is present in a molecule. Means if there is some molecule which having no symmetry operations, that means that molecule doesn't require any operation or any symmetry. There is some symmetry elements but there is no any kind of operation or very limited symmetry elements are there, then that molecule belongs to low symmetry. Right? So what is that? C1, CS, Ci, these point group belongs to low symmetry point groups. Another class is a high symmetry point group. Here we have a molecule like ammonia, like BCl3 molecule. In such an example, there is large number of symmetry elements and symmetry operations are present. Or also there is some examples where there is more than that symmetry operations and symmetry elements are present, that way what we expected over that, then that molecules belongs to a high symmetry molecules or high symmetry point group. For example, tetrahedral or octahedral or C infinity V, D infinity H, or we can say another examples where there is a large number of symmetry elements and symmetry operations are present, and therefore that is belongs to the this particular type of point groups. Okay, now in this particular chapter we want to basically understand, or we want to basically study two types of point group. What is that two types of point group? So first one is C type of point group and second one is a D type of point group. What is C type and D type? That means we have to make a label of that point group, like C infinity V, C2V or C3V. These are called as a label of that particular point group or name of that particular point group. And D type of point group means D infinity H, or we can say D2D, D2H, such kind of molecule point groups comes into the D type of point group. So here in C type of point group, as I said earlier, it includes CN, CNV, CNH point groups, where C is called as the axis of rotation. Any molecules which, obviously every molecule possesses the axis of rotation, whether that molecule, if it is rotated by whatever the angle, so that angle is called as n-fold axis of rotation, then you will get the CN type of axis. In definition of axis of rotation, we saw if any molecule is rotated to CN axis of rotation, then that molecule possesses what? Axis of rotation. So any molecule, if it is rotated 360 divided by theta, then you will get the CN axis. So here a molecule with CN axis belongs to CN point group. A molecule with CN axis belongs to CN point group. A molecule with CN axis and n vertical planes belongs to CNV point group. It is very clear that if any molecule having CN axis, where n is equal to 1, 2, 3, or C1, C2, C3, C4, in that molecule there will be a n vertical mirror planes belongs to CNV point group. For example, I have water molecule. In the water molecule, you can see here, suppose if I draw the structure of water molecule like this, H. So here in water molecule, this is a, let's say, a C2 axis, right? In this water molecule is rotated by 180 degree, you will get the equivalent configuration, and again when you rotate by 180 degree, you will get the identical molecule. So that means you required two rotation to get the original molecule. So in this water molecule, you have to there C2 as a axis of rotation. There is n number of vertical planes. Here n is what? 2. So there is a 2 vertical plane. One will be lying like this way and other will be lying like this way, right? So that means one vertical plane is going, which bisect oxygen atom. It goes in between two hydrogen atom and bisect the oxygen atom, while other vertical plane will goes over one hydrogen, then oxygen, and then another hydrogen. So it is going by this way. So both are vertical with respect to a principal axis. Everybody understood? If any molecule which possesses suppose C3 axis, then there will be n number of 3 vertical axes are there. So point group becomes a C3V. If a molecule C4 axis, then there will be 4 vertical planes are there. In short, we can say a molecule with CN axis and n vertical middle planes, that molecule belongs to CNV point group. Everybody understood that? When a molecule with CN axis and n vertical planes belong to CNH. Sorry. When a molecule with CN axis and n horizontal plane of symmetry. In the beginning, I told you that in plane of symmetry topic we studied that there are 2 types of plane, basically 3 types of plane. One is called as a, what is that? Vertical plane. Second one is a horizontal plane, and third one is a dihedral plane. If a molecule which possesses vertical plane, then that comes into the category that CNV point group. If the molecule possesses CN axis and n horizontal plane, then molecule possesses the CNH point group. Everybody understood? For example, C2H point group. In C2H point group, there is a C2 axis and 2 horizontal plane. So this could be understood with the help of this example. You just see here. Suppose I have this type of compound. One to dichloroethene. Now let's say or we can take example like instead of ethene we can take example of we'll take ethene. What is this? This is ethene. Let's say this is C2 axis. What is this? C2 axis. One plane which is perpendicular to C2 axis is this one. This is sigma H plane, right? Which is exactly bisect that molecule into 2 equal half. Another plane is a molecular plane like this. This is a sigma H. If any molecule possesses C2 axis and 2 sigma H plane, then that molecule has a C2H point group, right? That molecule has a C2H point group. So this is about the C type of point group. What are the requirement of C type of point group? A molecule possesses CN axis, and if that molecule has n number of vertical plane, then it is called as CNV point group. And if that molecule has n number of horizontal plane, then that molecule is called as a CNH type of point group. So here in C type of point group, basically we saw 2 category. One is a CNV point group, another is a CNH point group. Everybody understood that? Let me see here. This is CNH point group, CNV point group, and this is CNH point group. What is the requirement of CNV? CNV certificate requirement. What required for CNV? CN and sigma V. And for C2H, what is required for CN? Sorry. For CNH, what is required? Requirement CN and sigma H. So that is required for a CNH type of point group. Now next class is a D type of point group. In D type of point group, you have to remember that it includes again DN, DNH or DND type of point group, where D stand for dihedral plane. If any molecule which possesses the dihedral plane, then that molecule possesses or belongs to the D type of point group. The requirement of D type of point group is there should be a CN axis. I will show here what is the requirement of that. First, there should be presence of CN axis. Second, there should be presence of n number of C2 axis perpendicular to a CN axis, perpendicular to the molecular plane also, sigma H plane. So then that point, there are basically in DN type of point groups there should be a CN. I will write here so that you can understood. For CN, and there should be a perpendicular C2, that gives you what? DN type of point group. Okay. For DNH type of point group, what is required? There should be again CN as a axis of symmetry or a rotational axis. Then there should be a perpendicular C2, and also there should be a presence of sigma h. There should be presence of sigma h plane. Then that point group becomes a DNH point group. Everybody understood that? What is the requirement for DNH point group? CN, perpendicular C2, and sigma h. And what is the requirement of DN? CN and perpendicular C2. Third category for D type of point group is again CN, n number of n C2 axis perpendicular to it. Then there is a presence of sigma D type of point group. So what is that point group will be? D type of point group. In short, I will write here. In short, I will write that basically point group has point group has a basically of, let's say, two type. One is called as C type, other is a D type. For C type again there is a two example. One is called as CNV, another is a CNH. For CNV we required what? CN and n number of sigma V, and sigma and CNH we required CN and n number of sigma H. So this is the requirement of C type of point group. Okay. And now for D type of point group, what is we required? We required for D type we required again having different three category. One is called as DN, other is a DNH, and third one is a DND. So for DN, what is required? We required CN and n number of perpendicular C2. And for DNH, what is required? CN plus n number of C2 perpendicular to it plus sigma H. That is the requirement of DNH. And for DND, what is required? We required what? CN plus perpendicular C2, n number of perpendicular C2, plus there should be a sigma D, means diagonal plane. So this is the basic requirement of this point group, C and D type of point group. So basically we want to learn here these two class of point group. Now we will see here first example or first type of point group is a C infinity V. In your syllabus you have only 6 example or 6 different types of point group. Among that, first one will be the C infinity V. In this C infinity V point group, it is present in HCl molecule. For example, I will show here. I have one example, like suppose this is a example, right? Here in this particular example, you can understand that these two different colored shape, one is, let's say, we can say blue shape is called as hydrogen, and this other purple shape is called as a Cl. So this is a linear molecule. These two are joined together by a bond, right? It is a linear molecule having two different ends, right? Both are different. In this type of example, if you pass axis from hydrogen and then it goes through this bond to the Cl, and when you rotate that molecule you will get a infinity number of rotation, right? Infinity number of fold of rotations. So that means there, let's say this is a axis and that axis is along the z axis. So in HCl molecule there will be an infinite fold of rotational axis and there will be infinite fold of sigma v plane. Okay, therefore this molecule has a three different symmetry element. One is identity. Identity is what? That means if you keep this molecule remains as it is, if you do not change any kind of if you do not perform any kind of operation, or even though when you rotate that molecule 360 degree, then you will get the same molecule, then it is called as identity. And if you rotate molecule by infinity number of rotation, you will get the same groups, you will get the same configuration, then it is called as a C infinity as a rotational axis, and there will be a infinity number of vertical planes, so that is called as a sigma v plane. So there is only three symmetry elements. One is called as identity, second one is called as a infinity number of C2, and third one is a infinite number of sigma v plane. So that three, if you collect together and you will get the point group, that point group is called as C infinity point group. So what is the present, what symmetry elements present in C infinity point group? One is identity, second one is C infinity as a rotational axis, and third one is a infinity number of sigma v plane. Okay, everybody understood that? So we'll stop here for today's lecture because we have want to learn so many examples. So this is just the this is enough for today's lecture. Thank you for watching.